Hello everyone, my name is Yalin. Today I'm going to talk about the preliminaries for causal networks. Let's look at the question 1. Is Question A, is the AI system effective for men? Is the AI system effective for women? Question C, is the AI system effective across the populations if we do not know the gender of the person? Based on this table, we're gonna calculate. At first, we calculate the recovery rate from men. Advice is followed it. 81 divided by 80, 87, and then we get the number. And the next step is we calculate the recovery rate. Advice is not followed, and then we get the number, and then we compare those two numbers, and then we get the answer. About question B, and we calculate the recovery rate of women. Advice followed it. 192 divided by 263, and then we get number. So 30 more, so we calculate the recovery rate. Advice not follow, and then we get another number, and then we can compare those two numbers, and then we get the answer. Question C, calculate the overall recovery rate. Advice is followed. 273 divided by 350, and we get the number. And we also calculate the recovery rate. Advice is not followed, and we get another number. And then we compare those numbers, and we get the, when consider entire population without regarding the gender, the recovery rate advice is not follow is higher than the recovery rate advice follow. So in the conclusion, this AI system appears to work better for specific gender when the advice is followed. However, across the entire population without consider the gender, the recovery rate advice is not followed is higher than the recovery rate advice followed. This indicates that the AI system may not equal effective across the population. And let's look at the question 2. First, we need to calculate the probability of being 80 to 29 years old. Question 2, probability of being 30 to 40 years old is given you are at least 29 years old. And question 3, expected value of age. Okay, let's look at the questions. The probability of being 80 to 29 years old is 0.1544, and this the way to get this number. And about the question 2, probability is being 30 to 40 years old is given at least 20 years old, and we get 0.2736, and this is the way to get the number. And about the question 3, expected value of age. Expected value of age is the long-term average result of random variable based on its possible outcome. Correspond variable known as expected value in statistics, and this is the formula. And the first step, we need to calculate the x1, x2, x3, x4, and later on we need to calculate the probability of each age group. And then we base on the formula, and then we get the number. The final number is 49.1099. And let's look at the question 3. Use the following graph. Answer the following question. Question A. Then variable of persists z. Based on the graph, we can get the answer is y and w. About the question B, name variables that are not correlated to z. So which is x. The question C, name all of the parents of z. Based on the graph, we can get y and w. Right now, let's look at D. Name all of the ancestors of z. It is x. Name all of the children of W. Based on the graph, we can get Y and Z. Name all of the descendants of W, and we can get Y, Z, and T. The definition is about DAG. DAG is direct in-cyclical graphs. Every arc is direct. There are no cycles in the networks. About question J, the common cause of Y and Z in this context is a variable that in direct edge is going to both Y and Z. Let's look at the question 4. These questions tell us to draw the networks based on the independent assumptions for the following 5 questions. We direct networks are possible. Give formula for predicted last variable in the networks from marginal and pairwise conditional possibilities. Let's just do the quick review of that we learned this week in causal networks. On the first one is causal chain. Causal chain is the direct acyclical tree. We need to focus on 2 items, which are the direct and acyclic. These nodes in the causal networks is related to its parents and children by arrows. They are always direct from the parent node to the children node. Moreover, causal networks is acyclical, so it's not possible to start at one point, follow direction in the graph, and end up at the same point. Also, there shouldn't be any indirect arc. Let's look at the independence among variables. There are 3 types. The first type of independence in causal chain, where one variable affects the others, and we have 3 variables x, y, and z in the node are interrelated with arrows. X and Z are independent. That means X is the parent of Z and they have the direct relationship. One is the cause and one is the effect. Z is the parent of Y. Z is the cause, Y is the effect. The second type of the independence are common cause. In this case, there is one causal variable has effect on the Z variables. In this graph, Z cause X and Y. Z and X are independent to each other. Z and Y also are independent to each other. However, X and Y are independent to each other. In the third type is common effect, which is when the 2 variables cause third variable. In this graph, we can see X cause Z, Y also causes Z, but X and Y are independent to each other. Let's look at the question A. There is There are three nodes in the variable are given which x, y, and z, and the assumption is that x and y are independent. There is no information provided about z is being an independent or dependent variable with x and y. So when we draw the graph from this network, we have two options. The first option is a common effect type of graph when x, y cos z. X and y are independent of each other. The second option is all three variables x, z, and y are independent of each other. Let's look at the question B. In the question B also have three variables x, y, and z have additional assumption. This time x and y are not independent given condition z. In this case, the interdependencies between x and z and y and z. In this condition, we have the common effect interdependency type of connection where x and y cause the effect of z. The possibility of x given z, y given z equal to probability of x given z times probability of y given z. And the graph look like this. Let's look at the question C. The question C also has three variables x, y, and z with an additional assumption that x, y are independent given a condition C. And the assumption also states y is a measured last. We will use the causal chain type where x causes the effect of z, z causes the effect of y. The probability of x, y, and z equal to the probability of z cos given x times the probability of y cos given z. The graph gonna look like this. And let's look at the last question. In the last question, we have four variables x, y, z, and w. The first and second assumption are the same as the previous questions, where x and y are the independent and condition z, x, and y independent. In addition, we have our set x, y with w occurring with condition z, and the w measure last. This assumption that x and y are the cause of z, and z is the cause of w. So it represented by probability of x, y, z, w occurs to the probability of x times possibility of y times the probability of z given that x and y occur times the probability of w given z occurs. And we get the graph like this. About the question E, there are also four variables x, y, and z, x, y, z, and w. And the assumption given here that x and y are independent, and also z and w are independent. And x measured before z and w measured before w. Therefore, the variables are independent from each other. X is measured before z and y is measured before w. The graph gonna look like this. And there's no cause and effect relationship between two graphs. It's gonna be a separate graph. And about the question 5, and we need to calculate the probability of high school, estimate the possibility of high school or female, estimate the probability of high school occurs given female, and estimate the probability of female occurs given high school. And we get the total numbers first and then the number of high school, and this the formula 420 divided by 2440, and then we got the possibility. And about the question B, and and we got this formula. We use this formula, and then we get the probability of the randomly select person being either female or having complete high school. And about the question C, this is the conditional probability of having completed high school given that person is female. And the last question, this is the conditional probability of being female given the person has completed high school. And this is the formula, and we're gonna get the number. And this is the reference. That will be all for my presentation. Thank you so much for listening. If you have any question, you can email me. This is my email.